documentary will explore how some types of bacteria have been able to become resistant to antibiotics, as well as what effects this has on the host with the resistant bacteria, and what can be done to prevent resistance. Antibiotics are prescribed to help slow down or stop the growth of bad bacteria, which causes disease within the body. Usually antibiotics are prescribed in courses according to the type of disease. The courses are to be taken over weeks and even months. The problem of antibiotic-resistant bacteria begins when the antibiotics is not taken properly. For example, some people don't take the full course and stop when they are feeling better, even though there is still medication left. This means the harmful bacteria has not been fully killed off, increasing the chances of the bacteria becoming resistant. As stated in an article by the Australian Broadcasting Corporation, this misuse causes DNA within the bacteria to mutate. It then multiplies, taking over, making the host sick and then becoming untreatable. New methods and steps should be developed to replace antibiotics. They should also not have the same side effects as antibiotics do now. To further reduce the risk of these resistant bacteria, there should be more education available for the general public so they can be aware of the risks involved with taking antibiotics. There are a few ways in which this can occur. This drawing will demonstrate them. The DNA could code for a pump type of mechanism called an efflux, which pumps the antibiotic probiotics out of the human cell, preventing them from working efficiently. This can be seen at the top left hand of the drawing. The DNA could also create an enzyme that changes the chemical composition of the antibiotics so it doesn't work or breaks it down, shown at the bottom right. The antibiotic-resistant genes can be found on the bacterial chromosome, or small circle-like structures of DNA called plasmids. The genes can also be inherited, formed due to a spontaneous mutation, and even passed on from a different type of bacteria. There are many different effects this can have on an individual. It all depends on the individual person and their immune system, as well as which type of bacteria is resistant, as some bacteria is more harmful than others. For example, a type of bacteria that was picked up by an individual who had a cut somewhere on their body that got infected, compared to someone who ate a food in a foreign country containing the harmful bacteria. Both situations are different, involving different types of harmful bacteria, where both people would have been affected very differently. The infected cut could lead to having to amputate a limb, and in the other case the person could become very sick, have food poisoning, and be fighting for their life. By having an antibiotic-resistant bacteria living within an individual, diseases that aren't commonly associated with bacteria can occur, including obesity, diabetes, autoimmune illnesses, and inflammatory bowel disease. There are also some common side effects of taking the antibiotics, as shown in this picture. They include nausea, vomiting, stomach problems, and diarrhea, which can make it easier for the bad bacteria to cause disease in the host, as it also kills off some of the good bacteria that should still be in the body. Some other side effects of taking antibiotics include changing the body composition of the host. Tests were done by farmers on cows. They found that when the cows were on antibiotics, the animals gained more fat while eating less food. It was also discovered that if the antibiotics were started earlier in their life, the effects lasted longer and were more intense. This same test was done on mice, and the same conclusions were reached. This means the immune system is weaker, leading to less resistance against the harmful bacteria. This results in a faster rate of disease. It can be hard to know how to overcome this, with many differing sources of information saying different things. However, steps can be taken in order to try and prevent bad bacteria from becoming resistant to antibiotics, including limiting the use of antibiotics when something else could be used, especially during times when the immune system is not as strong. For example, young children and pregnant women should not be using antibiotics unless it is the only option. This is very important, as when a mother gives birth, her bacterial populations are the foundation to her child's immune system. If the mother's immune system is affected by antibiotics, the child's will be the same, leading to an immune system which might not be very strong. The individual patient's situation should be better assessed, and other alternatives to antibiotics should be given from the doctor. Another alternative is for the individual to take probiotics to help fight the harmful bacteria. If new medications are developed to only target the bad bacteria, the damaging of helpful bacteria will be reduced, resulting in a healthier immune system. However, it will take a lot of time, money, energy, and precautions to ensure the formula is correct. It will also need to be specific to all different types of disease-causing bacteria. Pharmacists will also need to be more careful with diagnosing and distributing medication. Healthy bacteria should be replaced after being killed by the antibiotics. If the antibiotics are taken properly as prescribed by the doctor, the new method of healthy antibiotics should be created so no good bacteria are killed off in the process and there are no long-lasting effects on the individual. To conclude, antibiotics are a type of medicine that is prescribed to help fight bad bacteria within a host. When the antibiotics are not taken properly, the harmful bacteria can become resistant. This can occur through mutation, passing down of the gene along with other methods of controlling how the antibiotics work. The resistant bacteria affects individuals in different ways and to varying severities, including causing diseases such as obesity, diabetes, autoimmune disease, and inflammatory disease. However, also taking antibiotics can have harmful, long-lasting side effects. To prevent the resistance of bacteria to antibiotics and similar medications, there needs to be more educating of the public about what can happen if antibiotics is not taken properly. New medications should also be developed to help combat this rise in resistant bacteria. It should only target the harmful bacteria, creating no side effects. Also, probiotics could be made readily available to help undo the effects of years of misused antibiotics.